Hello students, in the previous class we were doing graphs of a few important functions. So today we will continue with that. Yesterday I told you two graphs. Today let us go to the third graph. The third graph is polynomial function, that is quadratic function. So I'll take an example of quadratic function. Let the function be x square. So when it's a quadratic function, it will be a parabola. Parabola means the graph of parabola would be like this. The graph of x square would be like this. Yesterday already we have constructed the table, just we have to put the points. In the table, when x is -3, y will be -3 square, that is 9. When x is -2, y will be -2 square, 4. When x is -1, y will be -1 square, that is 1. When x is 0, y will be 0. X is 1, y is 1 square, that is 1. X is 2, y is 2 square, that's 4. X is 3, y is 3 square, that is 9. So we are plotting all these points like -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and when you join, you get this parabola. The domain of this function, you can see when you take domain, you will see on x-axis the graph is on the left side up to -infinity and on the right side up to infinity. So you can say the domain is from -infinity to infinity, or you can say it is the set of real numbers. A range you have to see on y-axis. On y-axis, the graph is starting at 0 and going up and up to infinity. So the range will be 0 to infinity. Next, the next function, fourth one, is a cubic function. The cubic function f of x equal to x cube. The function is from set of real numbers to set of real numbers. Again, when you plot x and y, when x is -2, y is -2 cube, that is -8. When x is -1, y is -1 cube, that is -1. When x is 0, y is 0. When x is 1, y is 1 cube. X is 2, y is 2 cube. On putting all these points on the graph, something like -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. When you join all these points, you will get a graph like this. Okay, so you can see the graph is going on the left side and right side up to infinity on x-axis. So the domain will be everywhere set of real numbers. Coming to range, even range you can see the graph is going down up to -infinity and going up to infinity. So the y is also minus infinity to infinity, that is set of real numbers. The next important function we are going to learn is rational function. Earlier that was the fourth one. So now fifth one is rational function. Rational functions will look in the form f of x by g of x, but the denominator should not be 0. So when you take the function, you will take set of real numbers, but 0 is not taken. Particularly, I will write the function first, then you will understand better. Instead of writing like this, first I will give you the function. The function is rational function 1 by x. So for this function, domain x, you can take any real number, but you should not take 0. Because if you take x as 0, the denominator will become 0. Denominator should not be 0. And the range y can be any number. So first you can plot the table. You can take values of x and y. If you take the value of x as -2, y will be minus 0.5. If x is -1, y will be -1. X can't be 0. If x is 1, y will be 1. If x is 2, y will be 0.5. So we have taken only a few points to plot. So if you plot this, -2, comma, minus 0.5, -1, comma, -1, 1, comma, 1, 2, comma, 0.5. And further also, if you take some more points, you can see the graph will be going like this. This is the graph of f of x equal to 1 by x. So you can see domain will be all real numbers, but 0 is not taken. You have the graph up to the left side minus infinity, right side up to infinity, but only at 0 you can't see the graph. There is no graph. And range, if you see, the graph is going down up to minus infinity and going up to plus infinity. So range, you can take the set of real numbers. So the next sixth function is modulus function. Modulus function looks like f of x equal to mod of x. For this function, x you can take any real number, y will get a real number, but y will be only a positive real number. Of course, which is the subset. So if you plot the table, you have to write the values of x and y. For that, actually, this modulus function is a piecewise function. That means it has two pieces. One is x and the other is minus x. X is when x values are taken positive or 0. Minus x when x values are taken less than 0. So if I take -3, -2, -1, if I take less than 0, the y answer will be minus of x, minus of -3, minus of -2, minus of -1. But if I take x as 0, x equal to 0, then y will be x only. Y will be 0 only. Next, if I take positive values 1, 2, 3, positive values, y will be x only. So x is 1, y is 1. X is 2, y is 2. X is 3, y is 3. This is how modulus function is defined. So if you plot these points and draw the graph, minus 3, comma 3, minus 3, comma 3, minus 2, comma 2, minus 1, comma 1, 0, comma 0, 1, comma 1, 2, comma 2, 3, comma 3, and join all these points which you got. That will be the graph of modulus function. The equation of this line is y equal to x. The equation of this line is y equal to minus x. That's why you have two pieces, y equal to x, y equal to minus x, for the graph of modulus function. Now, domain for this function, you can take any real number. The domain is set of real numbers. Because on left side, the graph will go up to minus infinity, and right side, it will go up to plus infinity. Both the sides, it is going to the ends on x-axis. So any real number. But range, if you see, the graph is only from 0 and it is going up and up. So 0 to infinity will be the range. The graph is not going down. The next is signum function. Seventh function, we will take signum function. Signum function is a piecewise function. There are three pieces. Y will be equal to 1 if x is any number greater than 0. Y will be equal to 0 if x is 0. Y will be equal to minus 1 if x is less than 0. So when you draw the graph of signum function, you will be taking the function from real numbers to real numbers. Okay. So when x is greater than 0, y is always 1. 1, comma 1, 2, comma 1, 3, comma 1, 4, comma 1, 5, comma 1. So greater than 0, y is always 1. Here I will not take 0. Because when x is 0, y is 0. So I will take this point. Now for x less than 0, y will be always minus 1. Like when x is minus 1, y is minus 1. When x is minus 2, y is minus 1. X is minus 3, y is minus 1. X is minus 4, y is minus 1. So joining all these points, you should not take 0. You are not supposed to take 0. So this is the graph of signum function. The signum function is actually written as mod of x by x. This is the way we write. And then if you take domain, you can see in domain the values of x on x-axis. You can go right side and left side without any end. Left side you can go up to minus infinity, right side you can go up to infinity. So domain x, you can take any real numbers. But for range, for y, There are only three answers. 1, 0, -1. Y will not take any values except these three. That is the range. Okay, next we will go to eighth function. The eighth function is greatest integer function. Greatest integer function is written like this. F is the function from R to R. But the meaning of greatest integer function is x you take any real number. X if when it is between n and n plus 1, where n is integer, then y will be equal to n only always. Even if x is equal to n, y will be equal to n only. What is the meaning of that? Like if x is -3, what will be y? X is -3. So y will be greatest integer function of x. Because -3 is an integer n itself. -3 is integer n itself. So the answer will be -3. Y will be -3 only. Right? Suppose x is 2. Y will be greatest integer function of 2. Again, because 2 is an integer, x is an integer, so y also will be the same, n, 2. If x is 0, y also will be integer 0 only. But the question arises, if x is -3.5, what will be y? So greatest integer function of 3.5 when you take -3.5, it is between -2 and -3. So you have to take the answer as -3 for y. If x is 7.7, what will be y? Greatest integer function of 7.7. 7.7 is between 7 and 8. So y you will take 7. So this you have to note it. And now when you draw the graph, when you plot the table, you will take -2, -1, 0, 1, 2, something like this. So for -2, y will be -2. For -1, -1. For 0, 0. For 1, 1. For 2, 2. Because we are taking integers. But if not integers, like if you take here -1.2, here -1.4, I will take some more. Suppose if you take here -1.2, here -1.4, here -1.6. So what is happening? All these numbers are between -2 and -1. So the answer will be -2. For y, for all these numbers, it will be -2. Similarly, if you take x as 0.2 or 0.4 or 0.6, -0.2, -0.4, -0.6, -0.8, all minus numbers. Because all these numbers are between -1 and 0, the answer will be -1 for all these numbers. numbers, y. Similarly, if you take x as 0.2, 0.4, 0.6, 0.8, for all these numbers, the answer will be 0. Y will be 0. If you take 1.2, 1.4, 1.6, 1.8 for x, all these numbers are between 1 and 2, so the answer will be 1. Y will be 1 for all this. Like this, you can make a table and now you can plot the graph. So you will have -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Something like this you will have. But for -1.6, -1.4 until -1, the answer will be -2. That means you will draw a line with an empty circle here. You are not taking -1. Now you will start at -1, -0.8, -0.6, -0.4. For all these, the answer will be -1. But you will not take 0. For 0, you will put empty circle. Next, you will start at 0, 0, 0.2, 0, 0, 0.4, 0, 0.6, 0, 0.8, 0. Like this, you will take until 1, but you will not take 1. Because 1 will start here, 1, 1, 1.2, 1, 1.4, 1, 1.6, 1, 1.8, 1. So all these answers will be 1, but you won't take 2 because 2 will start here. So this is how you will have the graph of this function, signum function. Sorry, greatest integer function. This is greatest integer function. I have written in the previous page. So if you see the domain, domain means the graph is going on the left side and the right side up to infinity. So the domain is any real numbers. X, you can take any real number. But if you see the range you will have only integers, z. Next, we will see some algebraic operations on functions. Algebra of functions. What is algebra? Whatever you learn in algebra. Suppose if you have a function f and a function g, then you can write f plus g of x as f of x plus g of x. Similarly, f minus g of x will be f of x minus g of x. If the function is multiplied by a constant c into f of x, you can take f of x and multiply the c outside. Similarly, if two functions are multiplied, fg of x, that means f of x and g of x are multiplied. When you divide the function f by g of x, that means you are dividing f of x by g of x. But the denominator g of x should not be 0. So this is all about the concepts needed for exercise 2.3. First, we will take some examples. Then we will go to the last exercise 2. The first example is if f of x is x squared, g of x is 2x plus 1, you have to find f plus g of x. That means you have to find f of x plus g of x. That means you will add x square and 2x plus 1. This is f of x, this is 2x plus 1. Suppose if you have to find fg of x, that means you have to take f of x into g of x. You have to multiply. F of x is x squared, g of x is 2x plus 1. You have to multiply. When you multiply, you will get 2x cubed plus x squared. Suppose if you have to do f by g of x. So you have to take f of x by g of x. F of x is x squared by g of x is 2x plus 1. These are the algebraic operations which I was telling. Similarly, one more example. If f of x is root x and g of x is x, how will you write f plus g of x? That means you will take f of x plus g of x. F of x is root x plus g of x is x. You will add up these two. How will you find f minus g of x? You will take f of x and then you will subtract g of x. F of x is given as root x minus g of x is given as x. Similarly, fg of x. It is f of x into g of x. Because f of x is root x, g of x is x, you will have x root x. If you have f by g of x, it is f of x by g of x. F of x is root x, g of x is x. This is how you will do algebraic operations on the functions. So now we can start exercise 2.3, the last exercise of this chapter. But after this, we have some miscellaneous examples and miscellaneous questions, exercise also. Okay, in this exercise, the first question. Which of the following are relations and which are functions? Or in other words, which of the following relations are functions? Which relations are functions? That also you can take as the question. Okay. So the first one is, you have to write domain and range also. The first one is 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. So the domain is set of all x's. 2, 5, 8, 11, 14, 17. Range is set of all y's. 1, 1, 1. Only 1. So you can see from the domain, all the x's are taken. No x is left. Moreover, there is no repetition of x. X is not repeating. So this is a function. This relation you can call as function. Second one, 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7. Now, when you write the domain, you will write all the x's. 2, 4, 6, 8, 10, 12, 14. For range, you will write all the y's. 1, 2, 3, 4, 5, 6, 7. So you can see from domain, all the x's are taken. And then you can see no x is repeating. That means this relation is also a function. Coming to the third one. 1, 3, 1, 5, 2, 5. First you will write domain, the set of all x's, 1 and 2. Next you will write range, the set of all y's, 3 and 5. You can see all the x's from the domain are taken. But what you can see is x, that is 1, is repeating. That's why this relation is not a function. Okay. Question number 2. You have to find domain and range. If you take f of x equal to minus mod of x, then what will be the domain? What will be the range? You will plot x and y. You will take some values like x is minus 3, minus 2, minus 1, 0, 1, 2, 3. You will know when x is minus 3, what you will have. I already told you about mod function. You will have minus of minus 3. That means it is minus 3. When x is minus 2, minus of minus 2, that is y. So it's minus 2. Similarly, when x is minus 1, it is minus 1. When x is 0, y is 0. But coming to 1, what will be y? Minus of 1. For 2, minus 2. For 3, minus 3. So you can see the domain. For x, you can take any real number. But what are you getting for range? Range, are you getting real number? Range, you are not getting real number. Oh, not only real number. You can say real number, but be more specific. Range, you will get negative numbers up to infinity and up to 0. There is no positive. In y's, there is no positive number. Isn't it? That's why this is the range. You must not remember the definition of mod of x. You will take mod of x as x if x is greater than or equal to 0. You will take minus x if x is less than 0. That's why I have taken here minus x. I have taken here minus x. Here I have taken only x. If you want, you can be more clear. For minus 3, minus 2, minus 1. What will you take y? Minus of mod of x. That is minus of minus x. Because mod of x you have to take minus x. Mod of x is minus x. That's why minus of minus 3. Minus of minus of minus 2, minus of minus 1 for all this. But for 0, 1, 2, 3, what will you take? Y you will take as mod of x, minus mod of x, because it's given in the function. So it is minus mod of x will be x. So minus 0, minus 1, minus 2, minus 3. In detail, if you see. Let us take the second part. The function is square root of 9 minus x square. If you have square root, under the square root you must have only positive numbers or zero. Under the square root you can't have negative numbers. If you have negative numbers, you can't find the square root. That's why. So what happens is, under the square root 9 minus x squared, it should be either positive or it should be 0. That means x squared minus 9 should be less than or equal to 0. X squared minus 9 less than or equal to 0. Or x plus 3 into x minus 3 less than or equal to 0. That means x plus 3 into x minus 3 can be less than 0. X plus 3 into x minus 3 can be equal to 0. So if it is equal to 0, x plus 3 will be 0, x minus 3 will be 0, x will be minus 3, x will be 3. Now how will you solve this inequality? For this you will take minus 3 and 3. And then randomly you can pick up here minus 4, in this part 0, in this part 4. We will take this and put the values of x. If you put minus 4 here, this is negative, this is negative. So you are getting a positive answer. So here you are getting a positive answer. If you put x as 0 plus 3, 0 minus 3. This is positive, this is negative, so you're getting a negative answer. If you put x as 4, 4 plus 3 into 4 minus 3. Both the answers are positive, so the final answer will be positive. That means here you are getting positive. But we don't want positive, we want negative. So we have to take from here to here. Minus 3 to 3. These values of x you get. X belongs to this interval. That means domain, the x's you can take from minus 3 to 3. Or x is greater than or equal to minus 3, less than or equal to 3. That is the domain. Coming to y. How will you be taking y? How you will be taking the range? If you see y, what are the numbers you will be getting? If you put, okay, y is square root of 9 minus x squared. If you put x as minus 3, you will get y as square root of c, that is, if you put x as minus 3. So the y values are starting with 0. And if you put x as 0, y will be square root of 9, that is 3. Y values will end at 3. Y values start with 0 and end at 3. That means the range of the function is from 0 to 3. In the beginning, it may look difficult, but if you practice, it is easy. Let's go to question number 3. The function is defined as 2x minus 5. You have to write f of 0. That means in place of x, you have to put 0. 2 into 0 minus 5. That will be 0 minus 5 or minus 5. Next, you have to find f of 7. In place of x, you have to put 7. 2 into 7 minus 5. 14 minus 5. That is 9. Next, you have to find f of minus 3. In place of x, you have to put minus 3. 2 into minus 3 minus 5. Minus 6 minus 5. That is minus 8. So we are getting y values by putting the values of x. That is the main intention. Next, the function t. Fourth question. The function t is mapping the temperature in Celsius to the temperature in Fahrenheit. Next, T of C is given as 9C by 5 plus 32. T of C means temperature in Fahrenheit. So first you have to find T of C. That means Celsius you have to put C. 9 into 0 by 5 plus 32. That is 0 plus 32, which is 32. That means when Celsius is 0 degrees, then Fahrenheit will be 32 degrees Fahrenheit. When the temperature, what I mean is, if you want, I will write something like this. It will be more clear. When the temperature is 0 degrees Celsius, you can call the temperature is 32 degrees Fahrenheit. Similarly, we have to find T of 28. So in place of C, you have to put 28. 9 into 28 by 5 plus 32. So you will have 9 into 28, 252, plus 5 into 32, 160 by 5. That is 412 by 5. Next, you have to find T of negative 10, minus 10. So in place of C, you have to put minus 10. 9 into minus 10 by 5 plus 32. 9 into minus 10 is minus 90 and 5 into 32 is 160 by 5. Or if you want it, instead of taking LCM, instead of taking common denominator, you can even cancel 5 ones, 5 twos. So minus 18 plus 32. And that is 40. So if the temperature is minus 10 degrees Celsius, that means the temperature is 14 degrees Fahrenheit. Now, next they are asking you to find C when T of C is 200. For this, we will go to the new page. T of C is 9c by 5 plus 32, it's given in the question. Now they are asking what is c when t of c is 200. So put t of c as 212. 9c I don't know. Then you can write 212 minus 32 equal to 9c by 5, because we are finding c. 200 minus 12 is 180 equal to 9c by 5. 9c is equal to 1818 into 5. And c will be equal to 180 into 5 by 9. 9 ones, 9 twos. So c is 100. This is what we call. That means if the temperature is 100 degrees Celsius, that means the temperature is 212 degrees Fahrenheit. So this question is used to change the temperature of Celsius to Fahrenheit, Fahrenheit to Celsius. Next question. We will see question number 5. You have to find the range of these functions. First one, f of x equal to 2 minus 3x, x belongs to R, x is greater than 0. Before doing these questions, I want to tell you a few tips and tricks. Suppose the function is having only numerator, no denominator. Then you can say domain will be any real number, any x you can take, no problem at all. But if the function is having numerator and denominator, then when you find the domain, if you want to find the domain, you have to take denominator is troublesome. It should not be C. It can be any. Next, if the function is having square root of something, instead of something, I will take square root of n. So when you find the domain, you have to take this n should be positive or zero, but not negative. Suppose if the function I will take in the denominator square root of any number or anything, then when you write the domain, n should be only positive. It can't be zero because it is in the denominator. So these all things, if you remember, it will be very easy. If you see this function doesn't have denominator, it has only numerator, right? But you are given condition. When you plot x and y's, x has to be greater than 0. That means x you will take 1, 2, 3, 4 like that. If you put x as 1, what will be y? Actually, greater than 0 means you can take still numbers like this. What are the numbers greater than 0? You can start with 0 0.1, 0 0.2, 0 0.4, something like that you can go. You can continue. So when x is 0 0.1, if you put x as 0 0.1 in the function, what will be y? 1.7. Because you will have 2 minus 3 into 0. When x is 0 0.2, What will you have? 2 minus 3 into 0.2. That is 2 minus 0.6. That is 1.4. When x is 0.4, what will you get? 2 minus 3 into 0.4. That is 2 minus 1.2. That is 0.8. Like this it goes on. If you take x as 1, y will be 2 minus 3 into 1. That is minus 1. If you take 2, y will be 2 minus 3 into 2. That is minus 4. If you take 3, y will be 2 minus 3 into 3. That is minus 7. Like this it goes on. So if you observe x, what can you see? What can you say about domain? X you are taking greater than 0, you can take up to infinity. What can you observe about range? From 1.7 it is decreasing, decreasing, decreasing. That means it is going up to minus infinity. And it is going up to 2. Because suppose if you take 0, x is 0, why you will get 2. But of course you should not take x as 0. You have to take greater than 0. So this is the range. Let us talk about 6th. I mean in 5th question only, 2nd. F of x is x squared plus 2. This is said x is a real number. So what will happen? If you plot the values for x and y, you can put x as 0, you can put plus 3 or minus 3, you can put plus 5 and minus 5, like that. If you put x as 0, 0 square plus 2. If you put plus or minus 3, 9 plus 2, 11. Plus or minus 5, 25 plus 2, 27. So domain, as they said, x is any real number. Range, if you see, observe carefully. The range is starting with 2 and going to higher and higher numbers. Third one already I told you. Already we did third one. F of x is x. X is a real number. Whatever is x, the same is y. X and y are same. So if x is minus 3, y is minus 3. X is minus 2, y is minus 2. X is minus 1, y is minus 1. X is 0, y is 0. X is 1, y is 1. X is 2, y is 2. Like that. Actually, I don't need to plot the graph also. Directly we can say what will be the domain and range. If you see the values of x, you can take any real number. The same is for y also, any real. That's it. So these are the questions in exercise 2. We can start miscellaneous exercise, but maybe we can't complete it. The remaining concluding part we will do. Miscellaneous examples we will see first. Higher level problem. Suppose some higher level problems. First miscellaneous example. F is a function from R to R. F of x is given as x plus 10. You have to sketch the graph. Total there are 4-5 examples. So first I will plot x and y. Like x I will take -3, -2, -1, 0, 1, 2, 3. When I put x as -3, y is 7. X is -2, y is 8. X is -1, y is 9. X is 0, y is 10. X is 1, y is 10. X is 2, y is 12. X is 3, y is 10. Because we have to sketch the graph, we have to plot these numbers. -3, 7. -2, 8. I will take little distance because it will not be sufficient. The place will not be sufficient. So what I have? -3, 7. I will put the lines also. 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. -3, 7. Where it will be? 1, 2, 3, 4, 5, 6, 7. Somewhere. -2, 8. A little near. -2, 8. -1, 9. 0, 10. 1, 11. 2, 12. 3, 30. This is how we will have the graph when you do it. You can extend this. Okay. Let's go to second example. R be a relation from Q to Q. R is defined as having ordered pairs A, B. A and B set belongs to set of rational numbers. And A minus B belongs to set of integers. Show that first one, A comma A belongs to R for all A belongs to Q. A comma A, I can say belongs to R. That is because A minus B, that is A minus A, you will get 0, which is an integer. Second one, show that A comma B belongs to R implies B comma A belongs to R. So if A comma B belongs to R, that means A minus B is an integer. Now if a minus b is an integer, it implies b minus a is also an integer. So that means b comma a belongs to R. The third one, a comma b belongs to R and b comma c belongs to R implies a comma c belongs to R. Because a minus b belongs to R, that means a minus b is an integer. B minus c is also an integer. So a minus b minus b minus c also will be an integer. Or a, you have to take a minus b minus c or plus b minus c. You have to. If you take plus, you will get a minus c is an integer. Then you can say AC also belongs to the relation R. This is what you have to do. So we have done enough of miscellaneous examples. We will continue more in the next class and we will go to exercise also. So with this we will end.